Right, so in this video, we're going to graph the equation x equals y squared plus 5. All right, we're going to focus on finding the intercepts and using the concept of symmetry to help us make a table of values, okay? That'll make it easier to graph x equals y squared plus 5. All right, so first thing I want to do is find the x-intercepts. So remember, to find the x-intercept, we're going to set y equal to 0. All right, so that's going to give us x equals 5 as my only x-intercept. All right, the y-intercept, again, the process set x equal to 0. So when I get y squared by itself, I get y squared equals negative 5. And if I take the square root of both sides here, I'm going to have a negative number underneath the radical here. Well, that's not a real number. We could get an imaginary solution there, but that doesn't do us any good when we're graphing equations here. So because this would give me an imaginary solution, actually two imaginary solutions, that means I don't have a y-intercept. Okay, so this graph is going to have a point here at the x-intercept at 5, 0. It's not going to move to the left at all. So I know this graph is going to start here and move to the right. Okay, that's helpful thinking when I start making my table of values in a bit. All right, let's check the symmetry. We're going to start with x-axis symmetry. So remember, when you're checking x-axis symmetry, you replace y with negative y. All right, we're going to clean that up a little bit. When we square that negative y, we get y squared again plus 5. Now notice that matches, again, with symmetry, I want to see that those equations are the same. That matches, so this equation is going to have x-axis symmetry, okay? That's very important. It's going to make graphing a lot easier. Real quickly, we'll check y-axis and origin symmetry. It's not going to have either, but I do want to show the steps in y. So y-axis, we're going to replace x with negative x, okay? When we divide by negative 1 there, we're going to get x equals negative y squared minus 5. Well, that obviously doesn't match the equation I started with, so no y-axis symmetry here. Origin symmetry, remember we replace x with negative x and y with negative y. Okay, when we clean that up, it's going to look exactly like what I just did with the y-axis symmetry, so it's not going to match, so no origin symmetry here. So let's use that information to make a table of values here, okay? So there's not a lot of help here with the intercepts because I've only got the one intercept, my x-intercept, okay? Again, the fact that I got an x-intercept and no y-intercepts tells me that this graph is going to move from here to the right, most likely, okay? I also need to understand I have x-axis symmetry. So if I plug in a value for x, I'm actually going to get two values for y, the positive version of that and the negative version as well. So that's important to understand. All right, so let's say, we look at our original equation. Let's say I just plug in 6 here for x. Okay, so let's do that. Let's plug in 6 for x. Okay, so when I solve this, I'm going to subtract 5 from both sides, and I get 1 equals y squared. Okay, so when I take the square root of both sides here, I get two answers. I get a positive 1, okay? But then I should also understand, using that symmetry, that I'm also going to get a negative 1. All right, so if I substitute 6 for x, I actually get two values for y. All right? Now, I'm going to be selective here with the next value I plug in for x, all right? Because this is y squared, I want it to be a perfect square, so I'm not getting decimal values. It's going to make my graph a little neater. So I'm going to choose to plug in 9 here. So I'll show the reason I make that decision, and this is a decision you guys are going to have to make going forward. So when I plug in 9, notice that when I get y squared by itself, I get a perfect square 4 on the other side. So that allows me to get a perfect square answer. So I'm going to get integer coordinates for y here. All right, so the square root of 4 is going to be positive 2, and then we can use that concept of symmetry to understand that also there's going to be a point at 9, negative 2 as well. Okay, so we want to plot these 5 points, these 5 ordered pairs, to draw our graph. So let's go do that. So graphing the equation x equals y squared plus 5, we've got our table of values, so let's use that. We had our y-intercept at 5, 0. Okay, we had our values at 6, 1 and 6, negative 1. You can see we're using that x-axis symmetry there to plot those points. Notice they're the same distance from the x-axis. Okay, and then we've got our points at 9, 2 and 9 comma negative 2. Again, you can see the x-axis symmetry in the graph. So now let's connect those points. And I've got what looks like a parabola kind of turned on its side there. So x equals y squared plus 5 is going to look like that. All right. So again, focus on finding the intercepts, understanding how symmetry works, and how that can make graphing easier for you.